Welcome to my presentation. In this presentation, let us try to find the area of a triangle using determinants. Let us say in this example, the vertices of the triangle are given to us as follows: -1, 2, and then 2, 2, and then -2, 4. Let's say these are the 3 points given to us, and we want to find the area of this triangle. In here, let us see where these 3 points are, and then let us draw a small graph for ourselves. And then in here, let's say this is 1, 2, 3, 4, and then on the x-axis 1, 2, 3, and on the negative x-axis, let's say this is 1, 2, and 3. 1, 2, 3, 1, 2, 3, and 4. This is 4. That's 4. And then here we have, let's call this as 4, and then this one as -1, -2, and -3. And now let us identify where these 3 points are. -1, 2. -1 on the x-axis, negative x-axis, and 2 units on the positive y-axis. So that is the point. So this one is -1, 2. The second point we have here is 2, 2. 2 on the positive x-axis, and then we going to go up 2 units to the positive y-axis. So therefore that point there is 2, 2. And then the third point we have is -2, 4. -2 on the negative x-axis and 4 units on the positive y-axis. So let us identify that. That is the point. So this is -2, 4. And then let's join these 3 points. Let's join these 3 points. When we join these 3 points, it becomes a triangle like that. And now we cannot use the geometry formula, which is 1/2 times the base times the height. We need to use another formula which we know, and we will use that as we go on. But we will use determinants to find the area of this triangle, and then find the area using that conventional geometry method a little later. So let's get started with that. So step number 1. What do we know? What do we know about the formula with respect to with respect to determinants? The area is given to us as plus or minus 1/2 the determinant of the vertices points, which are going to be x1, y1, 1, x2, y2, 1, and then x3, y3, 1. So that is the formula we have, and we will apply this formula to find the area of these vertices. So area is going to be equal to plus or minus 1/2 the determinant of -1, 2, 1, that is the first point, and then 2, 2, 1, that is the second vertex point, and then -2, 4, 1, that is the third vertex point of the triangle. So once we want to now find the determinant of this, and therefore to do that, this is how it's we're going to write it out: plus or minus 1/2 of -1, 2, 1, 2, 2, 1, and then -2, 4, 1. As we mentioned in the earlier example, that we will try to travel along a particular row or a particular column to be able to find the determinant of this particular of this example here. So therefore in here we're going to, let us say, travel along the first row, and according to our sign convention, the first row, column, first row will have a positive sign, negative sign, positive sign. We'll follow that sign convention, and when we expand this is how it's going to look like: plus or minus 1/2, and then we're going to travel. Since we're traveling along the first row, we take the first row, first column element, and then write the minors of that. And the minors of that are going to be 2 1 4 1, and then go to the first row second column element, which is -2, and the minors for that element are 2 1 -2 1, and then the first row third column element, the minors of that element are going to be 2 2 -2 and 4, right? And now we will expand this and see what we get. When we expand that, the area is going to be plus or minus 1/2 of -1 times 2 times 1 is 2, 4 times 1 is 4, minus 2 times 1 is 2, -2 times 1 is -2 times negative will be +2, plus 1 times 2 times 4 is 8, minus 2 times 2 is 4, 4 with a +4, right? Because negative times negative is a positive, and therefore when we simplify this, it's going to be 1/2 times -1 times -2, 2 minus 4 is -2, minus 2 times 2 plus 2 is 4, plus 1 times 8 plus 4 is 12. So we got all the math simplified here, and we can simplify this some more. 1/2 of -1 times -2 is +2, 2 times 4 is -8, and then 1 times 12 is 12. So therefore when we simplify this, we're going to get 2 minus 8 will be -6. -6 plus 12 is going to be equal to +6, and therefore 1/2 times 6 is going to be equal to 3. And therefore, as you can see, the area is going to be a positive quantity, not a negative quantity. Therefore, we're going to disregard the negative sign in the formula plus or minus, and then just going to pick the 3 value, and it is going to be 3 square units, whatever the units the problem takes on. So the area here is 3 square units. We were able to find the area of the triangle using determinants. In my next presentation, we shall try to check the same, we'll take the same coordinate points for the triangle, and then try to see if we can find the area of the triangle using the geometry formula.